Hi there, Algebra 1 students. This video is for section 8.3. This is for part 2 when we have a quadratic equation. Remember, that's an equation with an x squared, but it is not factorable. So, but we still need to graph it and get some good points. So, start it like you normally would, and always, we need to have our first step be where we find our a, b, and c. So a is the coefficient of the x squared, so that is 3. B is the coefficient of the x, that is 6. And c is what I like to call that plain old number hanging off the end. It doesn't have an x multiplied by it at all. So a, b, and c are what we would need if it was factorable. So we're just pretending for a moment that we don't know it's not factorable, because typically you won't know. So remember, a times c goes at the top of your x, which would be 6, and b goes at the bottom of your x, which would be 6. Now, we're looking for two numbers that multiply to give us 6 and add to give us 6. And 1 times 6 and 2 times 3 are the two numbers that multiply to give us 6. Neither of those add or subtract to give us 6, so this would be a nope, not factorable. That's okay, because we can still do a nice graph by finding the vertex and then using a table of values like we did when we first started graphing quadratics to find some other points. So let's start by finding that axis of symmetry. And remember, we have our a, b, and c written, so this should be not too bad. We are going to copy this equation, but we're going to replace the b with 6. And then we're going to replace or substitute a 3 where the a is. So what I've done is I've rewritten this formula or equation throughout the b, throughout the a. Make sure you have that negative out in front. It's negative b over 2a. Now, I'm going to substitute my a and b in there, but use different colors. So my b is 6, and my a is 3. Okay, don't skip writing this step, and don't forget that negative. Now, don't put this whole thing in your calculator. It'll give you the wrong answer. Simplify your numerator. Negative 6 would just be negative 6. 2 times 3 is also 6. Now, at this point where you just have a number in the numerator and a number in the denominator, you could put that in your calculator if you want. But you all know that negative 6 divided by 6 is negative 1. So x equals negative 1 is our axis of symmetry. So now what I want you to do is I want you to go to your graph, and at negative 1, I want you to put that, I'm actually going to do this in a different color just so it shows up better on the video. This is going to be the middle of our parabola. Oh, I'm putting it at the wrong spot. Put it at negative 1. I'm going to make this a solid line then. So that is going to be the very center of our parabola. X equals negative 1. And then we are going to ignore these little lines that I put here, because this is going to be the center. Okay, now if we figured out what the axis of symmetry is, we know half of our vertex. We know the x part of our vertex, because the vertex is going to be on this line, the axis of symmetry. Oh, hey, let's go back and figure out if our parabola will be a smiley face or a sad face. Whenever your a is positive, you have a smiley face. So we know it's going to be upward facing. We know the vertex will be on this line, but we don't know if the bottom of the vertex will be down here or here or here. So let's figure out what the other half of the vertex is. When x equals negative 1, we want to find the y that goes with it. This equation right here will give us the output for any input we need. or we have. So if x is -1, we can put -1 in there and find the output. Remember, f of x is just another way to write y. X is our input, y is our output. So I'm going to copy this equation, but when I get to the x, I'm going to leave a hole because I'm going to replace that x with a -1. So 3x squared, throw out the x, plus 6x, throw out the x, plus 2. And what are we wondering? What is y when x is -1? So we're going to substitute a -1 in there. Now this, you can put that whole equation in your calculator. This doesn't, let me tip it up a little bit, that shows a little better. So 3 parentheses, -1, make sure you're using the negative symbol for your negative number. And then don't forget the squared. And then plus 6 parentheses, -1, close your parenthesis, no squared on that one, plus 2. And we get -1. Don't clear your calculator when you're doing these because we're going to use this same equation again. So I'm just going to set that aside. So when I put all that in, I get -1. So that means when x is -1, y is -1. So that is where our vertex is. So now go to your graph, go over -1 and down -1. There's my vertex. And I know this parabola is going to open up. So that point right there will be the bottom. That will help us when we get down to the bottom of the page here and we have to talk about our range. Now what we want to do is, we can't factor to find more points, so we want to pick some points that are right next to our middle of our parabola. So this x value is at -1. So I'm just going to have you write your vertex in there. We want 2 other x values that are right next to our vertex. So this is -1, so we could pick -2 and -3, or we could pick 0 and 1. I honestly would pick 0 and 1 because those are very easy numbers to plug into the calculator. We don't have to worry about a negative. So these x values we chose, and to find the y that goes with them, we're going to use this same formula. So we're going to do 3x squared, but we're going to throw out the x, plus 6x, throw out the x, plus 2. And what are we going to substitute in there? 0. Now this one I probably would not put in my calculator because 0 times 3 is 0, 0 times 6 is 0. So this is the same as 0 plus 0 plus 2. So this equals 2. So when x is 0, y is 2. Now let's do it again with, oops, don't forget your squared. But this time we are substituting in x equals 1. So give you a minute to write that. And then I'm going to go to my calculator. Let's see if I can tip this so you can see it better. If you use this up arrow, I can go right, I don't have to type everything in again on that equation. Now that negative I don't want, so I'm just going to delete that. And what I'm substituting in is 1. So if I just delete the negative, where I had a -1, when I get to that negative, I hit delete. And then I can just hit enter. And I get 11. So when x is 1, y is 11. When I put this in my calculator, I got 11. Okay, now let's graph these 2 coordinate points. And then we can probably graph our whole parabola. So over 0 up 2, so start at the origin. We're not going to go right or left at all. We're going to go over 0 up 2. That's a point. And then we're going to go over 1 up 11, which is going to be a little bit of a problem because our graph ends at 10, but we can get close. So over 1 up, I'm going to say 11 is right there. Now we're going to use symmetry to find points on the other side of our parabola. And remember, if this coordinate point is 1 to the right of the middle, if I go 1 to the left, I can put another point there because this is the middle. So if this point is 1 to the right of the middle, I will have a point 1 to the left, because parabolas are always symmetrical. Let me extend my axis of symmetry there. This point is 2 to the right, so if I go 2 to the left, I'll have another point there. So we don't have to do a big table of values here because we can use symmetry to find those other points. Now let's try to connect these points with a nice smooth curve. It's very skinny. So do the best that you can. All right. One other thing I wanted to point out we could have actually cheated and used this right here. If you remember, C is always your y-intercept. So that is a point on the y-axis where your parabola crosses. So that point right there, which is the same as this point, 0, 2, that is your y-intercept. So I actually could have gotten that point right away without doing any work. We'll do that on the next one. All right, now let's fill in everything down here. Axis of symmetry, we know what that is. That is x equals -1. Don't forget, has to be x equals -1. It is a vertical line. It is a vux. So you need the x equals. Our vertex we know is at -1, -1. When I look at this graph, this is the bottom of my parabola or the bottom of a roller coaster, which means it's a minimum. And where is the bottom? It's at -1. So that the bottom or the top will always be the y value of your vertex. So this is the y value. It's a little confusing on this problem because our x and y are both -1. But when you are identifying the bottom or top or the max or min, you always want to use a y value. Domain, you know, is always all real numbers. I'm going to abbreviate it like that. And remember, you can use that symbol for all real numbers, the double-legged R. And range, those are y values. And I know my parabola ends, or the bottom, is at -1. If it's the bottom, that means it's the very smallest y value. So I want to put the little tiny point of my inequality by the -1. And we need the or equal to under there because we are saying all of our y values are greater than or equal to -1. We're equal to -1 right there at that point. All of the rest of the y values, that's what this y represents, are above or greater than -1. -1 is the very bottom or the smallest. This y represents all the other y values on the graph. Okay, if you need to pause the video or rewind, make sure you have a beautiful example all filled out in your notes. And then we are going to do one more in this video. So same thing, this one's a little trickier because we have some negatives, but let's begin by writing our A, B, and C. Our A is -2, our B is -8, and our C is 1. So A equals -2, B equals -8, C equals 1. Okay, now this one is not factorable. I can show you real quick, but we would have -2 up here and -8 here. Well, there's no way you're going to find two numbers that multiply to give you -2 and add to give you -8. So that's why we're going to use a table of values to find some other points. But let's find that vertex. That is probably the most important point on our parabola. So negative b. Remember, wrap up this b and wrap up this a in parentheses. And then we are going to substitute negative 8 in place of our b and negative 2 in place of our a. We have a lot of negatives in this one, so we have to be careful. So make sure this negative is part of the formula and our b is also negative. So we're going to have negative of a negative 8 in the numerator. All right, now negative of negative 8. If you're not sure, just put that in your calculator. Use the negative and then parenthesis, negative 8, parenthesis, hit enter, and it tells you, hey, that's positive. So if you multiply two negatives, you get a positive. This is like multiplying two negatives. This is like negative 1 times negative 8. Multiply two negatives again. No, this is multiply a positive and a negative, so we're going to get a negative, and 2 times 2 is 4. When I divide positive 8 by negative 4, I get negative 2. So x equals negative 2 is the axis of symmetry. So I want you to go to your graph. I'm going to try not to screw mine up this time. Go to x equals negative 2. And draw that axis of symmetry in, because we are definitely going to need that for when we do that reflecting those points over the axis of symmetry. Okay, so if we know the axis of symmetry, we also know half of the vertex. And while we're at it, let's go down here and write in the axis of symmetry. X equals negative 2. We already know that. Now, if we have an x and we want to find a y, that's when we go back to our original equation. And we are going to say, wherever there's an x, I'm going to throw it out. So I am substituting in numbers where these x's are. So I'm going to copy the negative 2, and then I'm going to put parentheses, put a big hole. Don't forget the squared. Instead of 2x squared, I have 2 whole squared minus 8x, but throw out the x, plus 1. I recommend you write this at least once. Once you have it in your calculator, you can just do that cheater thing, like I said, and go up and grab it out of your calculator. But write it out at least once. And what x value are we substituting in there? Negative 2. So there's a lot of negatives in this one. We're going to have to be really careful when we punch this one in our calculator. I want you to make sure that you are practicing punching this in your calculator also. I don't want you to try to do this for the first time on the test. I'm trying to turn on the light on my camera here to see if it helps the calculator show up better. But it doesn't seem to be working. Let me try something else. Try closing these blinds a little bit. All right, so I want to put in negative, use the negative button, negative 2, that's for that, and then parenthesis, and then negative 2 again, that's the x value that I'm plugging in. Again, whenever you're putting in a negative number, make sure you're using this button. Close your parenthesis, and then hit the squared button. Okay, now this is subtraction, so I don't want to use the negative button for this. I want to use the subtract. 8 parenthesis, negative button, 2. So make sure for that you're using subtraction. For a negative symbol, you're using this negative button. And then plus 1. And you get 9. Okay, so when x equals negative 2, y equals 9. So our vertex is at negative 2, 9. Okay, let's graph that. So we know it's going to be on this line over negative 2 all the way down, oh no, all the way up to 9. Now you might be thinking, ooh, this seems weird. The vertex is way up there. Well, let's go back. One thing I forgot is, see this A is negative? That means our vertex is going to be a sad face. If A is negative, your parabola will be a sad face or a frown. So this is going to be the top of my parabola, and it's going to go down. I also, let's not forget to go ahead and graph this y-intercept right now also, because that's going to give us 2 points on our graph. So C is always your y-intercept. A y-intercept means you have a y value of 1 and x is 0. So this is another point we can graph, and then maybe we won't even have to put 2 points in our table of values. So let's plot this point over 0, so don't go right or left, go up 1. So that's another point on our parabola. And that makes sense, right? Because it's downward facing. Okay, now this point is 1, 2 to the right of the axis of symmetry. Go 1, 2 to the left and put another point. So we already have 3 points on our parabola. Honestly, we could do a pretty good graph right now, but I want you to practice finding one more point. And we're going to write the vertex again. And remember, we want to pick a number an x value right next to -2. So here's -2. I'm thinking let's choose -1. So we want these x's to be right in a row. The next one that we might choose would be 0, but we already have a point there. So we're just going to figure out what happens when x is -1. Now, if you didn't clear your calculator, all you have to do is arrow up, and that -2 we're going to change to -1. And then keep going. All that stays the same. When you get to that other -2 in parentheses, make it a 1. And then there's our +1. And then hit enter, and you get 7. So this is 7. And again, what I did here was I did -2 throughout the x, -8 throughout the x, +1, and what I substituted in there is -1, -1. So I'll give you a moment there to get your notes up to speed. Make sure you have that. Make sure you have the 3 points that we already know. We're going to graph this point next. So if you go to the origin, you want to go over 1 to the left. So 1 to the left and up to 7, which is right there. Over -1, up 7. This point is 1 to the right of the axis of symmetry, so if you go 1 to the left, there's another point. 5 points is a great number when you are graphing parabolas. 5 coordinate points should be able to give you a nice parabola. All right, I'm going to turn my paper here and try to graph this. Remember, no corners, nice smooth curves. Arrows at the end. There we go. Not bad. So remember, the vertex will always be 1 point. That will be your turning point at the top or bottom of your parabola. In this case, actually, let's label that here. This is the top of the roller coaster hill. And then C, when you write your C, that is a point right there. C will always be the y-intercept. So if you are graphing a point on the y-axis, your x is 0 and your y is 1. Now let's fill in the bottom here. So we already know our vertex. We wrote it up there, -2, 9. Whoops. This is a maximum. because it is at the top of the roller coaster. So we have a maximum. Our vertex is a maximum. Because our parabola is downward facing, that is a max, which also means it is the biggest y value on the graph. And what is that y value? 9. Remember, the vertex is the turning point. That will always be either your max or your min. And when we're describing where the top or the bottom of a parabola is, we want to use y values. This is also going to help us with our range. So I'm going to do our range right now. Y and 9. These will always be the same. That's the biggest y value, so this time I want to put the big wide open mouth by the 9. And I want to say all the rest of the y values are less than or under 9. 9 is at the top. All the other y values are underneath or less than 9. And domain is all real numbers. Okay. That is it for this lesson. Now what I need you to do is turn the page and do the you try problem on the next page. Now you'll notice I messed up and didn't give you a graph. So as good as you can, I just want you to sketch a graph. I understand it probably won't be perfect because you're sketching it, but do your best to sketch a graph once you find all of this information. You have two very good examples to go by.